Hi, this is Mary Julian, and I wanted to demo my Project One code. So I'll first go over the functionality of the code, then I'll do a brief overview um, of the actual code. So if we open up the project, I'll set this to full size. The idea behind this is it will draw formation curves, and you can modify the angle and position of each point. So we start by drawing a pretty simple curve. We can select a point and modify this guy's angle. And this uses the standard formation math as a parametric function to plot out every point between 2 points, or every pixel between 2 points. So you can change the angle, which affects the vector. I've also normalized the vector so that its magnitude in the X and Y direction depends on how far the point is between, depends on how big the distance is between the 2 points. So this vector here that's going 90 degrees up, its magnitude depends on the next point. That produce the best looking curve without having to ask the user to specify a magnitude. So you can move the points as you'd like, and then add any more points that you want. Change the angle and create some nice looking curves. If your selected point is in the middle of the list, you can make a point just to the next position and to the right. So you can make interesting angles. I think this will be a good base for creating a UI in the future. Yeah, it's pretty interesting. And you can also delete any points that you want and redo their position. So this has led to me creating a couple different looking curves where you can have a curve that draws your signature, like what I have here. And these can be also the basis for creating a surface or creating shading. So let's go into the code real quick. So this uses the GTK C++ extension or package for the UI. So it's using this GTK builder and builder UI file. It creates an instance of this Caro helper. And every time you select a point, a new instance of this point data class gets created with a specific position, angle, and vector. Well, given the angle, I break down the vector. And the math for the formation curve is set in this function here, create Herm curve, where it takes in the position of itself and the position next in line, and follows the parametric function for a Hermitian curve. Yeah, I think that's all I wanted to talk about. Oh, and you can also save any image that you've created as a file. So if we save this test.png, you can see that it's been saved as a file here. Yeah. Cool. Thank you very much.